This class is on probability distribution of a discrete random variable. And for this first lesson, we're going to understand what certain things mean. Like, what is a discrete random variable? A discrete random variable has a numbered amount of possible values. There are no unlimited values that are possible. It has a countable number, maybe 5 possible values that are there, or so on. And the probability of each of those values happening is going to be between 0 and 1. And the sum of all those probabilities, of all those values that are possible, will equal to 1. But that means those are going to be the only possible values that can happen out of that event occurring. For example, the number of times I land on heads if I toss a coin 3 times. So I can either land on head 0 times, I can land on head 1 time, I can land on head 2 times, or I can land on head all the 3 times. That's my discrete random variable. Second example, the number of eggs I can break if a box of 10 eggs is dropped. So I can break 0 eggs and I can break up to 10 eggs. Anything in between is also considered. That's also a possible value that you can have. So that is going to be our discrete random variable, and that is going to be our discrete random variable. They have to be discrete. That means they have to be not continuous. Then we look at probability distributions, where the probability distributions of a discrete random variable lists all the possible values and their corresponding probabilities. Usually, the discrete random variable is denoted as capital X, and all the possible values are given as X. We will see that in an example and it will be more clear. Let's consider tossing 2 fair coins where we can obtain either 0 head, 1 head, or 2 heads. And X, which is a random variable, will represent the number of heads obtained in each trial. And we are told to draw the probability distribution for that random variable X. That random variable X consists of 3 possible values, which is 0, 1, and 2. And these will be small x's, which is usually used in the probability part, where the probability of X is equal to 0 will be the probability of getting a tails and tails, because you have 0 heads. And getting a tails in the first one, probability is 0.5. Getting a tails in the second one, probability is 0.5 again. And so, probability of getting tails and tails will be 0.5 times 0.5, which is 0.25. Then we go to 2 heads, and the probability of getting heads and the second one getting heads as well will just be 0.5 times 0.5, which again will be 0.25. If you want 1 head from those 2 coins tossing, you can either get head in the first one and the tail in the second one, or tail in the first one and the head in the second one. To get head in the first one, probability is 0.5. Tail in the second one, probability is 0.5. So 0.5 times 0.5 for heads then tails. And the same thing for tails then heads, also be 0.5 times 0.5, which will give us 0.25 plus 0.25, which is also 0.5. And so when we are drawing up our probability distribution table, we have something like this. We have the random variable X, and we have the probability that the random variable is equal to one of the possible values. Remember, these are small x values. So when the random variable is equal to 0, then the probability of that is 0.25. When the random variable is equal to 1, the probability of the random variable being 1 is 0.5, as we found earlier, where we have 1 head out of the 2 tosses. And when the random variable is 2, meaning we get 2 heads after tossing, the probability of you getting 2 heads from your 2 tosses is 0.25. And if you add all of this up, you'll see that the sum of the probability will equal to 1. We move on to an example where we are told that a fair square spinner with sides labeled 1, 2, and 3, and 4 is spun twice. The 2 scores obtained are added together to give the total of X. Draw up the probability distribution table for X. So for this, firstly, we need to know what are the possible values you can get. Remember, 1, 2, 3, and 4 is what you're getting. And you're spinning it twice. And you're adding them together. That added amount is your random variable. So when you add these up, we have already learned how to do that using the table. We get this. So what are the possible values that you can get for our x, which is the sum? We can get 2, we can get 3, we can get 4s, we can get 5s, we can get 6s, we can get 7s, and we can get 8. So those are going to be the possible values that you can get for your random variable. Now, when you're drawing up a probability distribution table, you have your random variable x, and below it you have the probability that your random variable is equal to a specific value of x. The random variable x can be 2, can be 3, can be 4, can be 5, can be 6, can be 7, and can be 8. We have a total of 16 outcomes here. 4 from the first spin and 4 from the second spin gives you 4 times 4, which is 16. From that, 1 out of those 16 is a 2. 2 out of those 16 is a 3. 3 out of those 16 is a 4. 4 out of those 16 is a 5. 3 out of those 16 is a 6. 2 out of those 16 is a 7. And 1 out of those 16 is an 8. And if you sum all of these probabilities up, you will get 1. And this right here will be the probability distribution table for this example right here, where you have your random variable x at the top and the probability that the random variable is equal to that specific value that is possible from the event occurring. Next example, the following table shows the probability distribution for the random variable v. So we're given the probability distribution table. We need to find the value of this constant c. And we also have to find the probability that v is greater than 4. What are the values that are there greater than 4? 5 and 6. And we'll see how we use that information to answer the second part. But first, we have to find the value of the constant c. What do we know about probability distributions? That the sum of all the probabilities of the random variables will equal to 1. So we have that 0.05 plus c squared plus c plus 0.1 plus 2c plus 0.05 plus 0.16 is equal to 1. If I rewrite this well, I'll get c squared plus 3c plus 0.36 is equal to 1. Then I take 1 to the other side and I get c squared plus 3c minus 0.64 is equal to 0. Solving this quadratic equation to find the value of c will give me my first possible value of c being 0.2 and my second possible value of c being negative 3.2. But we also have another condition for probability distributions, that each specific probability is between 0 and 1. So this is between 0 and 1, yes. If we square my negative 3.2, I will go beyond 0 and 1 because I'll get 10.24, which is beyond 0 to 1. If I square 0.2, I will get 0.04, which is between 0 and 1. And therefore, this is going to be our actual c value that we are looking for. So c is equal to 0.2, which gives us the probability of v equals to 3 is 0.04. Probability of v is equal to 4 is 0.3. Probability of v is equal to 5 is 0.45. Now we are told find the probability of v being greater than 4. V being greater than 4 means that v can be either 5 or v can be 6, because remember, we have a countable number of possibilities. So v can be 5 and v can be 6. So v can be 5 or v can be 6. If v can be 5 or 6, that means the probability of you having that will be the probability of you getting v as 5 or the probability of you getting v as 6, which means you will be adding those probabilities up. And you adding them up will give you 0.45 as the probability of your discrete random variable being 5, plus 0.16, which is the probability of your discrete random variable being 6. And this in total will give you 0.61. That's going to be the probability that your discrete random variable is 5 or 6. And in other words, that your discrete random variable is greater than 4. Finally, there are spaces for 3 more passengers on a bus, but 8 youths, 1 man, and 1 woman wish to board. The bus driver decides to select 3 of these people at random to allow them to board. Draw up the probability distribution table for Y, the number of youths selected. So because the guy is just selecting 3 people, we can have at least 1 youth selected. Why? Because we have 8 youth, we have 1 man, and we have 1 woman. If he's selecting 3, then he needs to have at least 1 from here. Why? If he takes 1 man and 1 woman, he will have selected 2 out of the 3. He still has 1 space, so 1 youth will definitely be selected. So the smallest amount of youth that we can have selected is 1, and the largest amount is going to be 3. Those are all our 3 possibilities. Either we have 1 youth selected, or we have 2 youth selected, or we have all the 3 selections being youth. Those are going to be our possibilities of the discrete random variable. Now we have to draw the probability of your discrete random variable being each of these values, right? Now we go and look at the actual selections. So remember, we have 3 spaces, right? In the first scenario where one of them is a youth, therefore the first one, let's say, is a youth. Because in selection, the order doesn't matter. And this one is either a man or a woman, and this one is also the man or the woman. And so the total possible selections is 8C1, because we have 8 youth and 1 selection, times 2C2, because we have 2 man/woman, and we have 2 spaces for that man and woman. This just gives us 8. What are the total possible selections? That's just going to be 10 combination 3. Why? We have 10 people in total and we have 3 spaces. So 10 combination 3. And that 10 combination 3 is 120. To find the probability, we will do the success events over the total events, which is 8 over 120, which will give you 1 over 15. Next is the selection with 2 youth. So we have a youth here, and either a man or a woman here. For that, the possible selections are 8 combination 2, because you want to select 2 youth out of the 8 that are available, multiplied by 2 combination 1, because they are 2 man and woman, or man/woman, and we need only 1 out of those 2, so we're choosing 1. That will give me 56, and therefore the probability of you having 2 youth will just be 56 divided by 120, and this gives us 7 over 15. Finally, the last possible selection, where all the 3 that were selected were all youth, and that is just 8 combination 3. Why? Because you have 8 youth and you are selecting 3 out of them. That gives us 56. So the probability, success events over total events, that's 56 over 120 again, which again gives us just 7 over 15. If we count up the probabilities, the sum, we get 1 over 15 plus 7 over 15 plus 7 over 15, which does give us 1, which does confirm that this is going to be our probability distribution table for the discrete random variable Y, not X. So these are the changes that will be made. So it depends on the discrete random variable letter that they give you. Here they gave you Y, right? The previous one they provided you with V, but the usual one that we use is X, as it was stated in the first slide here.